Hello, today I'm going to present our research project. The topic of our project 2 is Raphael's painting classification. Let's look at the dataset. We have 28 images in total, and 12 images are Raphael images painting, and 9 images are not Raphael images, and 7 images are disputed images. We need to predict whether these 7 images are real or not Raphael images. We use the 21 image here. We crop it. Since every image is very large, it cannot be included to the VGG16, so we cropped the original image to small image patches, and the size of the small image is 224 times 224. Finally, we got 7,104 small images in total. We divided the whole dataset into two parts. The first part is the training dataset. It has 5,000 images. And the second is the testing dataset. It has 2,104 images. We build our model on the training dataset and tested on the testing dataset. And then we have 7 disputed images. We crop each image with the same size here, 224 times 224. For image 1, we got 210 small images. Similarly, we got different number of images. And as for the method, we use the VGG16 to extract the feature vectors of these images. The most obvious method for us is using the transfer learning. We just modify the last layer of the neural networks and train it on the training data and test it on the testing data, and make the prediction of the disputed images. And the second method we use is traditional supervised learning method based on the extracted feature vectors by the VGG16. Here we use 4 methods. I will show you their performance later. Now let's look at the transfer learning. This is the structure of VGG16. We modify the last layer so we can output a 01 class label. And then we train the whole VGG16 on the training data. We got a training accuracy of 99. And then we tested it on the testing data, get a testing accuracy 96. Here we can see, since the testing accuracy is very good, that means the VGG16 network can perform well on the classification task. And then we use this model to predict the 7 disputed images. For image 1, we have 210 small images. We make the prediction of these 210 images. We got the results like this. 101 images are classified to not Raphael image, and 109 images are classified to Raphael image. So we got a probability 51.9. That means we have 51.9 confidence say that this image 1 is a real Raphael painting. Also we get some probabilities for other images. If we set the threshold at 60, and we can see image 7, image 23, image 25, image 26 can be regarded as real Raphael paintings, while image 1, image 10, and image 20 are not Raphael paintings. Okay, let's look at the traditional supervised learning method. Since the extracted vector feature vectors by VGG16 has 496 dimensions, we first reduce the dimension of these feature vectors, so it can improve the efficiency for classification task. Here we use the PCA to do the dimension reduction. We choose 100 principal components, and you can see it gives 97% of the feature information. It's very good. And then we perform the traditional supervised learning method based on the PCA reduced dimension vectors. First, we use the KNN to find the best parameter K. We use 10-folder cross validation, and finally we got we got the knowledge that when K equals to 3, the model KNN has the best performance for our data set, and then we test the model accuracy. On the testing data set, we get accuracy like this. And after testing the model, we predict the results on disputed images. We got a similar table like transfer learning. You can see for image 1, 165 are classified to not Raphael image, and 45 are classified to Raphael image. If we set a threshold probability to 60, we can see image 1, 10, 20 are not Raphael images, while these 7, 23, 25, 26 are real Raphael images. Also, we use the logistic regression method, and we got a testing accuracy about 93.9, and also we show the prediction results of disputed images. You can see it from here. Also, we use this vector machine, random forest. Here we use totally 4 supervised learning methods. We make a comparison between among these 4 methods. We use the ROC curve to show the performance of these 4 methods. We also use the testing accuracy to compare these 4 methods. We give the reason why as support vector machine have the best performance. We explain it by the bias and variance trade-off. Finally, we make a summary of the prediction results on disputed images. We plot the prediction results of 4 methods here. We found the prediction results of transfer learning are in alignment with the result of traditional supervised learning methods. And finally, we give a small conclusion here. Thank you.